all right. Okay, looks like it's working. So there's two presentations. One's going to be on configuring flows, and the other's going to be on the Docker images for Corda 4 open source. So configurable flow responders originally came out of a requirement of B3I. As you know, B3I is a consortium of 10, 20 members, each with uniquely different backends for their systems. So basically, B3I had a problem. Either they had to provide a Corda app which handled every single possible backend for their members, or they had to provide a way for extending flows and allowing them to be configured for whichever obscure backend they have. So the way we can do this in Corda now, since Corda 4, there are two ways of configuring a flow. You can subclass an existing flow, or you can manually specify an override. So the first example would be subclassing a flow. So in this case, we have a really, really simple flow. It responds to a flow called base initiator, and the base responder, all it does is it sends a message back to the initiating party, and standard function, all it sends back is a string, but we need to configure this for different backends depending on what particular backend they have. So we want to override the function, get message from backends, and so let's create a subclass. So this is for an IBM backend. All you would do is in plain Kotlin, plain Java, you would just define a subclass using standard object-oriented mechanisms. And in this case here, all we're going to do is we're going to respond that we're a DB2 WebLogic-based engine. Well, it takes, I added an extra second to simulate enterprise software. So what we've done here now is the node will be running with two flows registered to base initiator. And in Corda 3, what that led to was sort of random behavior. Depending on which flow is encountered first by the Corda app loader, that will be the flow that was used to respond to the base initiator. What we changed in Corda 4 is that we have a deterministic approach now. We actually count the number of hops that you are from flow logic. So in this case here, the base responder is one hop because it's a direct subclass of flow logic, whereas the IBM responder is two hops and is therefore considered the most concrete version of the flow, and it's what's used to respond. Okay, but that's all well and good. In some scenarios, you won't be able to subclass a flow just because it's so different. You might be dealing with a backend that's just so obscure that you can't extend an existing flow. So Corda now provides this concept of a flow override, which is something in the node config. So this is the syntax you would add to your node configuration. You specify your initiating class, and you specify your responder. And internally, what Corda does is it assigns a maximum weight to this override. The same logic is triggered, but it has integer max value as the number of hops from flow logic. So this will always be selected as the responder for base initiator in this case. We've also added it to deploy nodes, because a lot of people use deploy nodes to build their nodes for production. And there's a new method available in the more recent versions of the Gradle plugins, which is exactly, you specify your initiator, and you specify your responder, and that will generate the node config for you. That's really it. It's nothing fancy, but it does allow customers to have actual Corda apps.
Can you override the initiator too?
You can override the initiator, but it's done in a slightly different way, and it hasn't changed from Corda 3. In Corda 3, what would happen in Corda 4 and 3, if you create if you go back to, in this class here, we have base initiator, as it's initiated by. If you created, let's say, a special initiator for your specific nodes, On the initiating side, it opens a connection to the counterparty as normal. The counterparty would do a class hierarchy. So it would, let's say your initiator is called special initiator. It opens a flow the other side. Obviously, special initiator doesn't exist on the other side because it's unique to that initiating party's node. And it will find the next one up, in which this case will be base initiator, and the logic starts from there.
So special initiator inherits from base initiator?
Yeah.
Okay.
And the responding node does a class walk to find the first node in its the first class in that hierarchy that it knows about, and then it uses the same logic to respond as if it was that one. So in this case here, we registered the IBM responder to be initiated by base initiator, but if you started a flow called special initiator, that subclass base initiator, the responding node would go, oh, do I know about special initiator? No. Okay, go up one level. Do I know about base initiator? Yes. And then use a logic which you've defined in your flow overrides or your subclasses. This is only part one of the work. There is also work to do on RPC invocation for configurable flows, in the sense that we accept the fact that there's different backends for responders. A Corda app tends to come with a web interface most of the time, and at the moment, people are expected to manually configure initiators. So if you had to use special initiator, you would have to change your web app to call the special initiator directly. You can't just say, start flow base initiator, and it would find the most specific version. You'd have to manually call special initiator in your RPC invocation.
So I can ask you a quick question.
Sure.
So we know that whilst Corda doesn't have human-computer interaction, there's actually very few places the flow can go to. So can you just give us a few examples of the type of backend we are talking about here?
Just think of any point a flow has to interact with an existing system. So for insurance, it will have to contact a risk engine to determine the premium it should charge on a reinsurance contract. Any time it has to interact with an existing system, if your BNO members do not have harmonized backends, this is what you have to use.
Okay, well, I always thought that the flow cannot actually initiate pretty much anything. You know, it cannot send a message anywhere. It cannot invoke a HTTP call.
Yeah, it can do all these things. Flows can do anything.
I know it can, but I thought it was not recommended.
You can't do it.
As long as they're idempotent.
You have to be careful that because the flow is asynchronous, you have to be careful that the flow doesn't end by the time that you get the response back from the
Okay, fine.
In fact, most of these, they're blocking. So the worst that can happen is, let's say I open a HTTP GET, right? And something happens, your flow is killed before it gets a chance to complete. It'll go back to the previous checkpoint before the HTTP call.
So just be really clear then, because I need to make sure I understand this as well, which is flows will checkpoint if you call send or send and receive. That's where all the magic happens. If you don't use a Corda API, it just doesn't go to that. If you don't use a Corda API to make one of these calls, because you're not going over the P2P network, you're just making you're just using an HTTP connection. That the flow doesn't go to sleep at that point, so that thread is blocked until you get a response. Yeah. And if it fails, as you say, or if the node blows up, it will replay from before, and it will then do the same thing again.
Yeah, so that's why we say anything the flow should do is idempotent. You shouldn't create two entries in your backends. You should design it in a way.
Fine. Okay.
But we should advise clients not to do something mad whereby they call something that blocks for 3 days whilst the user does something, because very bad things will probably happen. Yeah,
I think there is actually under the covers, there is support for HTTP suspend and that kind of stuff. There is, yeah.
So there's support for this thing called asynchronous flow operation, and you basically just wrap up your asynchronous HTTP request into that. As soon as you send off the request, the flow suspends, serializes to disk, whatever, and then it wakes up when you get the response. I think Andreas added it in Corda. I think it came in Corda 4. Yeah. or .3, I don't know, one of those. It's been around for a while.
It's an important part of it.
Kind of, yeah.
Do a call and then wait till some human does something which sends the response back.
Yeah, but what you can't do is send messages to arbitrary queues and things like that. That's what the human-computer interaction is really about, from what I understand. And it also bakes in durability. When you're making HTTP calls to random hosts and stuff, you get no durability, right? I don't know. I guess it's maybe a discussion for another time, perhaps. Yeah.
Yeah, John?
So would this be the best practice of clients doing integration with backends that don't use the JVM? I mean, say there's an insurance company that's got a .NET stack, and they want to have some kind of Corda implementation, but they're not ready to throw away their .NET work. Would this be the preferred way of doing?
Yeah,
integrating with that.
If your .NET application provided a way to be called from Java, if it even if it provides a simple REST interface, yeah. So this was a real thing. So in BCI they have two members, one called Liberty, one called Munich Re. And they had completely different backends to do some calculation. I can't remember what it was. And one of them was using a .NET server backed by ASP, and the other one was using something sensible like a MQ broker of some kind. So they had to write two versions of the flow basically and provide it to their members. Whereas now what they can do is provide a single Corda app and then allow the members to extend it only where it's necessary.
Yep, sorry, retract my statement. There is an internal API called Flow Async Operation, but it is not currently available to Corda app developers. But there are some things in the platform that use it. I think what we'll do in the future is make it a public API, potentially. In the meantime, if you want to have an asynchronous operation, then you can submit a Jira ticket and then we can add it. Thanks.
Okay, so I think that, any other questions on flow responders? Yeah, sorry.
How does the initiator flow determine what responder flow logic to run?
So the initiator doesn't ever act. So on the initiating node, this never gets invoked. It's on the responding side. So basically, when I open a session with, so you see in the Corda apps, you initiate session, or basically, when you do that, the message sent across tells the other side what flow that session's in the context of.
Which party has it, so that's
so
deployed as part of their Corda app?
Yeah, so that they would expect this would have to be deployed as part of the Corda app.
So will that end up being like, it won't be one Corda app if you have multiple backends for different systems on different businesses. It could end up being
so take, for example, I'm a business network operator. I provide a common Corda app for my members, and then my members can develop their own Corda app, which they put in the same node, in the same Corda apps folder, which will override the default flows.
It gives you reusability of your initiator flows.
Yeah, exactly.
Okay, cool.
And a lot of the time, most members will have the same kind of flows. It's only a couple which tend to be awkward, from what I've seen.
One question: what happens if you've got two subclasses?
The node blows up on startup. It prints out. It doesn't blow up. It doesn't blow up. It prints a very concise error message, and it says, "I have detected flow abc.x and abc.y with equal weighting. Please specify flow overrides."
You could inadvertently trigger that situation to start Corda app.
Yeah, but it tells you which they are and what to do to fix it, basically. Yeah. Dimos, you? There's one next to you.
One of those will work. Okay. So regarding the subclassing,
are there any best practice or recommendation? Because I was thinking that when we subclass a flow, we should only override specific methods that the author of the base class wanted to override.
Yeah.
And we should not call any flow APIs, right, to maintain backwards compatibility.
So that's
with the existing flow, right, the initiator.
So you have two choices. If you're the app developer, you can make an abstract flow and only have the abstract method that should interact with the backend open, or just as in this case, just make sure the method's open. Most methods, by default, they won't be overridable. You have to make them open.
In Kotlin.
Yeah. And in Java, you can make your methods protected or whatever it's called. Yeah. I mean, all this does is it allows Corda to do what every other kind of developer does normally, right? You wouldn't create a brand new class every single time you want to make a small change. This just brings it to Corda, basically. Okay, so the other one is on the Docker images. It's even shorter than this one. So let's see. How do I open? Okay. Okay, so this is only about open source. We haven't released the enterprise images yet, and they are not finalized. I will do another presentation on the enterprise images when they are finished, and we've got agreement basically what they're going to be. So everybody wants to use Docker. Everybody wants to use Corda. So this. Sorry? Mike's on board now. I think even Mike is pro Docker.
I'm trying to distract Mike from something else.
Yeah. So, all this, our Docker images are the simplest Docker images you can imagine. All they contain is corda.jar and one special thing, which is the config generator, which I'll go through in a second. So we currently provide two images. We have a Zulu JDK-based one, which is backed by Ubuntu, and we have the Corretto JDK one, which is backed by a CentOS image. This is because of the Java apocalypse. We couldn't provide the Oracle JDK, and we couldn't provide OpenJDK because there's no supported runtime for them in terms of backports. So what does it do? It allows people to run Corda within Docker, and it supports automatic config generation for two cases. We have if you want to join Testnet, or if you want to register and join an existing compatibility zone. And it also, by default, allows you to use bootstrap networks. So here's alignment's wrong. This is the example. If you wanted to join Testnet, what you need is you specify your public address in the same way you would normally put it in the P2P config in your node configuration, and you need the one-time download key, which you get from Testnet. If you run this code, if you run this shell script, this will go to Testnet, download your certificates, put them in the certificates folder, which you've mounted using this volume here. These are standard Docker volumes, so I'm mounting the certificates folder and I'm mounting the config folder into the Docker image. And once this container finishes, you will have a fully ready to run node. It will have certificates and it will have a configuration. And then to actually run the node, you would just invoke the same image without the config generator commands. And that's it. Corda is up and running on Testnet as far as this is concerned. The exact same thing is available for compatibility zones. Using the config generator with -- generic, it will go to a doorman, it will register with the doorman, it will wait for the CSR to be signed, it will put it into the right place, it will build your node configuration with the environment variables you've passed in, There's a few other environment variables available in the documentation. You can specify your P2P port, your RPC port, your password for RPC, etc., etc. And again, running it afterwards, you just run the Docker container without the the Docker image without the config generator flag. And that's it. I mean, under the covers, it is just calling Java jar, Corda.jar, and mounting in some folders. The end. Any questions about Docker images?
So when you...
Sorry.
The next logical step would be installing a Corda app, I would imagine. So are you supposed to step into the container and copy?
No. So I left this off, but you see here, this is so slow. Let me just delete this border. It was nicer on my computer. But yeah, here, so this line here, we are using a Docker volume to mount the Corda apps in, so.
Oh, I see.
All Corda, I see if I can make it bigger, sorry. So you see that line which ends in /opt/Corda/Corda apps?
Yep.
We're mounting the Corda apps into that folder. Yeah. So you don't have to install them, they're just provided to the image.
Do you follow ports there?
Yeah, so by default it exports, I left them off, but by default the Docker image will export the default RPC and P2P ports. Only if you override them in the config generation phase do you have to modify them. But it's just a standard Docker command. You do -p port.
How about the Corda version?
Each image has its own version. So these ones are currently using the nightly snapshots. So this is Corda 5 in inverted commas, but the officially released ones are Corda 4, and it's in the image name.
Okay. Would that be like Corda 4 point minor version, just in case we have patches and stuff? Is that also going to be pre-built?
Yeah.
Okay.
Whatever version is in the build.gradle when Corda is released, it automatically labels these images as that.
Nice. Thank you.
So like patches, with -32117, it just gets done.
Perfect.
Sorry, Stefano, quickly. When I said ports, I meant forwarding to the Docker container itself.
So by default,
Sorry.
In the config generation phase,
Yep.
It defaults to 10,021 for RPC and 10,022 for P2P.
Yep.
And the Docker image is built to expose those two ports.
Okay. Understood.
If you change the ports either during generation phase or manually in the node.config, you will be expected to pass the ports to Docker. But fingers crossed, people who are running it in Docker know about port forwarding and exposing it in Docker. In the documentation, the actual docs show how to do that.
What do you think is the difference between this method and, say, the likes of Compose, Docker Compose, in terms of flexibility of adding more nodes as you have a setup like this deployed?
So in Docker Compose, you would use this image.
Yeah.
And then it's exactly the same. So at the moment, people are building their own images to put into their Compose files or their Kubernetes files. You would just use this image in your Compose file. So you define a service like Node A. Instead of doing a build context, you would have an image, and you just put this image, the Corda/Corda Zulu, blah blah blah.
Okay, so using the Compose file with tools like Kubernetes, you'd have more flexibility in those tools to add kind of more chunks of the image, I guess, or more chunks of the compose, like more containers like on the fly.
Yeah, yeah.
Doing it, just running a script every time like this.
Yeah. So if you wanted to do, this is for someone who just wants, this is an example of just running it in a terminal, right? If you were doing it in Compose, you would have to convert, so the volumes would have to be put into the Compose, and the environment would have to be in Compose when you register. But that's like an advanced feature. We don't have an example Kubernetes or Compose Corda yet.
Are you owning like containerization from the platform things? Are you not?
I do not know exactly who is owning what. At the moment, it's on a bit of a back burner, but we will be releasing. There is going to be an enterprise version of this that will have a firewall. There'll be a firewall image, a DB migrator image, and a Corda node image to support enterprise features.
So how is the database managed in the Docker, troubleshooting-wise? How do we get to the database?
So the database lives outside. So normally, if you're using a standard JDBC string in the node config, you just connect to the remote database. But again, here, if you look down here, I am mounting in the persistence folder.
Yeah.
So if they're using H2,
yeah,
you mount in. So this Docker image is empty; it just contains Corda. You mount in all your folders to support, configurability.
Okay. So you're doing it like a volume mount, you mean? So it's really sitting on the local machine, so you can look at it. When you shut down the Docker, you can load the H2 somewhere else. It will be clean.
Yeah. So.
Okay.
Yeah, we mount in config, we mount in certificates, we mount in persistence, and we mount in logs, which allows them to be used after the container is shut down.
Got it.
I think volume creates a mirror because if you lose the Docker container, you lose all the state inside of it.
You have to use a volume, otherwise, once a container dies, there's nothing available. Anything else?
So this question on that one. So basically this Docker, this gives us self-contained CPU and managing the process that's being used on the box, but as far as disk and everything, that still has to be managed at like the server level.
No. So this image is designed, so most people that will be running Corda inside Docker will be running it with some sort of orchestrator. Like Kubernetes or Docker Swarm or even plain old Compose. So this is mainly for them.
Got it. Almost like a shell to allow them to orchestrate it, even though it's a high install.
Yeah. So I don't know how to describe it. It's just like a self-contained application, basically.
Yeah.
So just to be sure, like this approach of scripting it is kind of just for education, deployments you'd need to go with the Compose route and cluster.
No, not necessarily. Like for example, let's say you want to make a completely cloud provider agnostic virtual machine image, you would use this. Because at the moment, if you want to run on Google Cloud, Azure, or Amazon, you have to have different templates and that kind of stuff. In the future, you can just delegate to the Docker image, and as long as it supports Docker, you're good to go.
Thank you.
No worries. Okay. And thanks. Thank you, everyone.
Thanks, Stefano. Good job.
Thank you.